A pleasant day, everyone. We are now on Lecture 4 in General Mathematics, and today we will talk about rational functions. Rational functions are used to approximate or model more complex equations in science and engineering, including fields and forces in physics, spectroscopy in analytical chemistry, enzyme kinetics in biochemistry, electronic circuitry, aerodynamics, medicine concentrations in vivo, wave functions for atoms and molecules, optics and photography to improve image resolution, acoustics, and sound. Rational functions are commonly applied on problems involving work and distance. And for this lesson, we have these learning objectives. At the end of this lesson, you will be able to define and differentiate rational functions, equation, and inequality. Investigate the behavior of the graph of rational functions. But before that, let's review about polynomials. In definition 2.1, a polynomial function p of degree n is a function that can be written in this form, where a sub 0, a sub 1, up to a sub n are elements of all real numbers, and a sub 0 is not equal to 0. And take note of this, n is a positive integer. Each addend of the sum is a term of the polynomial function. So if you have one term, it is called as monomial. If you have two terms, it is called as binomial. If you have three terms, it is called as trinomial. And if you have more terms, it is called as polynomials. The constants a sub 0, a sub 1, up to a sub n are the numerical coefficients. The leading term is a sub n, x to the power of n, and the constant term is a sub 0. Now, what is really a rational function? In definition 2.2, a rational function is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial function, and q of x must not be equal to 0 because it will make the function undefined. Observe from the definition of the rational function, which is just a ratio of two polynomials. Here are some examples of rational functions. Function f, which is equal to x minus 2 over x plus 3. Observe that the numerator is a polynomial, the denominator is also a polynomial, therefore, function f is a rational function. Now we have here another example. Function g, which is equal to x minus 5 over x squared minus 8x plus 7. Observe that the numerator is a polynomial, the denominator is also a polynomial, therefore, function g is also a rational function. Now we have function h, which is equal to x over x plus 7. Observe that the numerator is a monomial, the denominator is a binomial, therefore, function h is a rational function. Now let's identify the following if it is a rational function or not. We have here function g, which is equal to the square root of x minus 2 over x plus 1. This can be rewrite as x minus 2 to the power of 1/2 over x plus 1. Observe in the numerator, we have here x minus 2 to the power of 1/2. The exponent of the numerator is a rational exponent. This is not a positive integer, so therefore, this is not a polynomial. For the denominator, x plus 1, this is a polynomial. So therefore, function g is not a rational function. Now for function m, which is equal to x minus 2 over x plus 3, observe that x minus 2 is a polynomial. X plus 3 is also a polynomial. So therefore, function m is a rational function. Now let's proceed to function r, which is equal to x to the power of negative 2 over x squared plus 4x plus 3. Observe the numerator. It has an exponent which is equal to negative 2, which is not a positive integer. So, the numerator is not a polynomial, and the denominator is a polynomial, so therefore, function r is not a rational function. Now let's proceed in evaluating rational function. This can be illustrated using this example. So, if f of x is equal to x squared plus 4x minus 13 over x minus 3, evaluate f of 2. Now, ang tip dito sa pag-solve ng evaluating rational function, ang gagawin lamang ay yung f of 2, di ba f of 2 man dito, yung 2 lang natin ay isa-substitute yan sa value ng x. So, lahat ng mga merong x dito ay re-replacean yan ng value ng 2. So, this can be shown by this. F of 2 is equal to 2 squared plus 4 times 2 minus 13 over 2 minus 3. Perform the operations and we have this result and we have the final answer which is equal to negative 1. Okay, so now let's proceed on differentiating rational functions, rational equations, and rational inequalities. But before that, let's review first about rational expression. In definition 2.3, a rational expression is an expression that can be written as a ratio of two polynomials. For example, we have 3x over x plus 1. The numerator is a polynomial. Denominator is also a polynomial. So therefore, this is considered as a rational expression because it is a ratio of two polynomials. We have another example which is x plus 1 over x squared plus 5x plus 6. This is also an example of rational expression. Now let's define rational function. Rational function is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial function, and q of x must not be equal to 0 because it will make the function undefined. The example of rational function is this function f, which is equal to x squared minus 4x minus 5 over x plus 3. So, now we will proceed to rational equation. It is just an equation involving rational expressions. Notice these are rational expressions, right? And with these rational expressions that is involved here, we also observe that there is an equal sign. So that means it can be called as rational equation if you see here an equal sign and as well as there are rational expressions involved. Now let's proceed to rational inequality. It is just an inequality involving rational expressions. So this is a rational expression. However, the symbol that has been used here is less than, which is an inequality symbol. So since this is an inequality symbol, this is considered as a rational inequality because it is a rational expressions. It is an inequality that involves rational expressions, and you can observe that there is an inequality symbol. Observing the 3, we'll observe that it can be called as a function if it is written in a functional form and which is equal to a specific rational expressions. And rational equation, kapag meron siyang nag-i-involve na rational expression at saka may nakikita tayong equal sign. ang rational inequality ay nag-i-involve din siya ng rational expression, pero ang ginagamit niya na symbol ay inequality symbol na pwede niyan ay less than, greater than, less than or equal to, greater than or equal to. Now let's classify this. You notice here that these are rational expressions. And we notice that there is also an equal sign. So therefore, this is called as rational equation because it is an equation that involves rational expressions and also it uses an equal sign as a symbol. Here, we have here h of x, which is equal to 3 over x plus 1. This is a polynomial over a polynomial. So this is a ratio of polynomials. So therefore, this is called as rational function. And the next is 3 over x minus 2 less than or equal to negative 1. Take note that there are rational expressions that has been involved. And the symbol that has been used here is less than or equal to, which is an inequality symbol. So therefore, this is called as rational inequality. For this, there are rational expressions that has been involved and the symbol that has been used is an equal sign. So therefore, this is called as rational equation. So we are done with the concepts as well as with the definition of rational equation, rational function, and rational inequality. We will now proceed on graphing rational functions. Now I will present to you the procedure in constructing the rational graphs. We have the step 1, which is find the domain and range. For the step 2, solve the x and y intercepts. Step 3, find the asymptotes. Step 4, construct the table of values and plot the points. Step 5, sketch the graph using smooth curves to complete the graph between and beyond the vertical asymptotes. So, let's start with finding domain and range. Domain of a function is the set of all values the input or a variable x can take. For the range is the set of all values that y or f of x having these values will give you a general initial idea on what will the graph will look like. For example, we have here function h, which is equal to 2x minus 4 over x plus 4. To find the domain of the rational function h, we need to start with creating an equation where the denominator is not equal to 0. So we have here our denominator, which is x plus 4. This must not be equal to 0. Because if this would be equal to 0, it will make the function undefined. Next to that is we need to solve the equation. And to solve this, x must not be equal to negative 4. What we did, we just only transpose this positive 4 to the other side. It becomes negative 4. So, for our domain, we can write our answer in this form. The set of all real numbers except negative 4. Or you could have negative 4 to negative infinity union with negative 4 to positive infinity. Negative 4 is the restriction because this is the value of the x that will make the function undefined. Now let's proceed in giving example on finding the range of the rational function. For example, we have the function h, which is equal to 2x minus 4 over x plus 4. We can rewrite this as y equals to 2x minus 4 over x plus 4. our goal here is we need to write this one into an x in terms of y. Since it is written in y in terms of x, isulat natin siya. Ang goal natin ay isulat natin dapat to, marirewrite natin dapat to into x in terms of y. So to do that, we have to first to cross multiply these two. So you'll have y times x plus 4 equals to 2x minus 4. After that, you need to distribute this. So this becomes xy plus 4y is equal to 2x minus 4. Observe that there are common terms with values x. So we need to combine these two terms. So you'll have xy, from positive it becomes negative 2x equals to, from positive 4y it becomes negative 4y minus 4. After that, you need to find its common. So you need to factor out by using factoring by GCF. So you have the factor which is x, and you'll have y minus 2, which is equal to negative 4y minus 4. After that is you need to divide both sides by y minus 2. So you'll have x equals to negative 4y minus 4 over y minus 2. So we already rewrite it. We already write it in the form of x in terms of y. So to find the range we have here, hence y is not equal to 2, otherwise the denominator is 0. So our range here on the function h is equal to all real numbers except 2, or from 2 to the power to the from 2 to negative infinity union with 2 to the positive infinity. Now let's proceed in finding the intercepts. Intercepts are the points on the graph that lie on the x-axis when y is equal to 0, or y-axis when x is equal to 0. So let's have an example here. Find the intercepts of h of x equal to 2x minus 4 over x plus 4. So to find for the y-intercept, we need to let x equals to 0. Remember, kapag y-intercept, ano yung mazi-0? Yung x ang mazi-0. So you have here y, which is equal to 2x minus 4 over x plus 4. Ang mangyari lang ay isa-substitute natin yung value ng x, which is equal to 0. So you have 2 times 0 minus 4 over 0 plus 4. So perform the operations and you'll have the final answer, which is negative 1. And we have now 0, negative 1 as our y-intercept. Now let's proceed in solving x-intercept. We need to let y equals to 0. So substitute the value of y, which is equal to 0. 0 equals to 2x minus 4 over x plus 4. Cross multiply, so this becomes 0. So it's just equal to 2x minus 4. Then transpose it to the other side. You'll have 2x equals to 4. Then divide it by 2 on both sides. You'll have x is equal to 2. So therefore, our y-intercept here is 2, 0. Hence, the x-intercept of the rational function h is 2, 0, and the y-intercept is 0, negative 1. Now let's proceed on asymptote. An asymptote is the line that a graph keeps approaching but never touches it. Asymptotes can be vertical, horizontal, or oblique. So, in vertical asymptotes and horizontal asymptotes of a rational function, we have this concept. Let f be the rational function. The graph of a rational function defined by f of x, which is equal to the ratio of polynomials. So these are polynomials, where p of x and q of x have no common factors. So the graph of f has vertical asymptotes at the zeros of q of x. Second, the graph of f has one or no horizontal asymptote determined by computing the degrees of p of x and q of x. So, observe that if the degree, if the highest degree in the numerator and the denominator are just equal, then what we need to do is we need only to divide the numerical coefficients of the highest degree. So you'll have y is equal to a sub n over b sub n. For letter B, the axis or the line y equals to 0 as a horizontal asymptote if n is less than m. And C has no horizontal asymptote if n is greater than m. So in horizontal asymptote, we need to look sa degree ng highest degree ng polynomial. So dito, we'll have n and we have here the m. So, ma-illustrate natin yan gamit itong example na to. Find the vertical and horizontal asymptotes of the graph of this rational function. So we have the function h, which is equal to 2x minus 4 over x plus 4. And to find its vertical asymptote, we learned a while ago that to find vertical asymptote, we need to equate the denominator to 0. So we have x plus 4 equals to 0. Then, simplify this one, so you'll have x equals to negative 4. So therefore, our vertical asymptote is x equals to negative 4. And for our horizontal asymptote, we need to look at into the highest degree of the polynomial. And we have here degree 1. And take note, for the numerator and denominator, we have the same degree, which is 1. So what we need to do, we need to divide its numerical coefficients. So for the numerator, we have 2. For the denominator, we have 1. So we have y equals to 2 divided by 1, which is equal to y equals to 2. So this is now our horizontal asymptote. Now let's have another example. For example, this function r, which is equal to x minus 2 over x squared minus 5x minus 14. So to solve for the vertical asymptote of this function r, we need to equate the denominator equal to 0. After that, we need to factor this quadratic na form. So you'll have x minus 7 and x plus 2 as our factors, which is equal to 0. After that, equate the x minus 7 equal to 0 and the x plus 2 equals to 0. So you'll have x equals to 7 and you'll have x equals to negative 2. So now let's proceed on solving horizontal asymptote. Observe that the highest degree in the numerator is x. You'll have the degree here, which is 1. And here we have the leading term, which is x squared, and the highest degree is 2. So you'll have y, which is equal to x to the 1 over x to the 2. And this 1 here serves as our n, and this 2 here serves as our m. So since n is less than m, therefore our horizontal asymptote is y equals to 0. This is based on the concept that we discussed a while ago. Now let's have another example. For example, we have this function s, which is equal to x cubed plus 3x squared minus 1 over x squared. So to solve for the vertical asymptote, we need to equate the denominator equal to 0. And after that, take the square roots on both sides. So you'll have the square root of x squared equals to the square root of 0. And you'll have the value of x, which is equal to 0. For the horizontal asymptote, observe that the leading term for the numerator is the x cubed, and for the denominator, which is x squared. So you'll have this. And the highest degree for the numerator, which is equal to 3, that serves as our n. And for the denominator, we have the highest degree, which is 2, that serves as our m. Observe that our n is greater than m, so therefore our horizontal asymptote is no horizontal asymptote. So now we learned the basic concepts on graphing. Now let's try another example and let's simultaneously show the different steps. So for example, we have this function h, which is equal to x minus 2 over x plus 3. So step number 1, find the domain and range. So to find the domain, so we need to remember that our x plus 3 must not be equal to 0 because it will make the function undefined. Then after that, you simplify this, so you'll have x is not equal to negative 3. So therefore, our domain here is all real numbers except negative 3, or negative 3 to negative infinity union with negative 3 to positive infinity. The restricted value of x here is negative 3 because it will make the function undefined. Now let's proceed in solving the range. Solve for x in terms of y. So we have the function y is equal to x minus 2 over x plus 3. What we need to do with this is you need to cross multiply, so you'll have y times x plus 3 equals to x minus 2. After that, you need to distribute this one, so you'll have x times y, you'll have xy, plus y times 3, you'll have 3y, equals to x minus 2. Then, combine like terms, so we observe that we have like terms here, which is the x and the xy. So we have xy, from positive, this becomes negative x equals to negative 3y minus 2. So, since meron silang common, so pwede natin silang applyan ng factoring by GCF. So you'll have x times y minus 1 equals to negative 3y minus 2. In order for us na yung x na lang yung matira dito sa left side, we need to divide both sides by y minus 1. And the result is x is equal to negative 3y minus 2 over y minus 1. So we already write it in x in terms of y. Hence, y must not be equal to 1, otherwise the denominator is 0. So the range of function h is equal to all real numbers except positive 1, or 1 to negative infinity union with 1 to positive infinity. Now let's proceed to step 2. Solve for x and y intercepts. When solving for y-intercepts, we need to let x equals to 0. So what we need to do here, we need only to substitute the value of x, which is equal to 0. Then perform the operations, and you have here y equals to negative 2/3. So you have the y-intercept, which is 0 and negative 2/3. For the x-intercept, we need to let y equals to 0. So We have here as our y, which is equal to 0, equal to x minus 2 over x plus 3. So, ang gagawin natin yan, i-cross multiply natin, so you'll have the 0. Then, yung matira dito, cross multiply 1 times x minus 2, you'll have x minus 2. Then, i-transpose natin yan, you'll have negative x equals to negative 2. Then, divide both sides by negative 1, then you'll have x equals to 2. So, our x-intercept here is 2, 0. Hence, the x-intercept of the rational function h is 2, 0, and the y-intercept is 0, negative 2/3. After the step 2, we will proceed to the step 3, which is the asymptotes. In finding the vertical asymptote, we need to remember that in the vertical asymptote, you need to equate this with 0. So after that, you'll have x equals to negative 3. And for the horizontal asymptote, you need to observe the leading term for the numerator and the denominator and observe the highest degree that they have. And here, we have here 1, and here we also have here 1. So they have the same degree. So our n and our m here is equal. So what we need to do, if our n and our m are equal, then we need to divide the numerical coefficients. So we have here 1 divided by 1, so you'll have y equals to 1. For the step 4, we need to construct table of values and plot the points. So sa pag-plot natin sa points, ang gagawin natin, kung for example meron tayong graph, i-plot muna natin yung mga asymptotes. So this is the asymptote which is x equals to negative 3, which is our vertical asymptote. And for the horizontal asymptote, which is the y equals to 1, itong naka-red na line. Ngayon, ang gagawin natin, yung pagpili ng points natin, it must be on the left side and on the right side of the asymptote. So, for example, dito, anong left side ng vertical asymptote natin? So, we have negative 5, negative 4, at marami pang iba. Pwede kang mamili ng maraming points niyan. At on the right side of that, you'll have 0, 1, and 2. And i-compute lang natin yan, i-substitute lang natin dito sa function, at ito yung mapuproduce natin ng mga values ng mga y. After natin na-produce itong mga values ng y, i-plot natin yung mga points, at ito na yung mga points niya. After ng pag-plot ng points, then we will use the smooth curve sa pag-graph. I-connect lang natin yung mga points. I-connect lang natin yung mga points na meron tayo dito. And always remember na yung graph natin, it will be approaching to the asymptote, but it will never touch. No? Hindi yan magta-touch sa asymptote. Pero mag-a-approach lang yan. So, katulad nito. Ayan. Let's have another example. For example, we have the function f, which is equal to x cubed minus x squared minus 5x minus 3 over x cubed plus 4x squared minus 3x minus 18. So, step number 1, find the domain and range. O paano pag-find ng domain? First muna, i-factor muna natin itong function na to. So, ito yung mga factors niya. Pag-factor natin, we need to equate the denominator na dapat ang denominator natin ay hindi yan mag-i-equal sa 0. Because if this would be equal to 0, it will make the function undefined. So therefore, our domain here is all real numbers except negative 3 and except positive 2. So ito yung domain natin. Yung range natin, medyo mahirap siya isolve. Kasi, ang hirap nito isolve gamit ang pag-solve ng pag-rewrite natin sa x in terms of y. Pero meron tayong ibang strategy niyan. So, ang gagawin natin, mag-proceed muna tayo sa step number 2. Solve the x and y intercepts. So to solve the x and y intercept, for the x-intercept, we need to let y equals to 0. So we have here y equals to 0 equals to the value of this specific function. Then cross multiply, so this is just equal to 0, equals to x plus 1 squared times x minus 3. Then equate this x plus 1 squared with 0. Then another one, we have x minus 3 equals to 0. So we have x equals to, take the square root on both sides. Take the square root on both sides. So you'll have x plus 1. Then after that, transpose the positive 1 to the other side. You'll have x equals to negative 1. So you have the x-intercept, which is negative 1, 0. At yung isa naman na case, isa naman na factor, you have x minus 3 equals to 0. So you'll have to transpose this to the other side. It will be x equals to positive 3. So you have another intercept, which is 3, 0. For the y-intercept, we need to let x equals to 0. So i-substitute lang natin sa value ng x yung 0. Then i-perform natin yung operations at yung magre-result niyan is 1 over 6. So therefore, our y-intercept here is 0, 1, 6. Hence, the x-intercepts of the rational function h is negative 1, 0, and 3, 0. And the y-intercept is 0 and 1, 6. Now let's proceed to step 3, which is the asymptotes. So for our asymptotes, yung vertical asymptote natin, ang gagawin lang natin, i-equate lang natin yung denominator natin equal to 0, and you produce x equals to negative 3 at saka x equals to 2. Pero madali lang din yan, titingnan mo lang yung domain. Kung ano yung nirestrict sa domain, yun yung vertical asymptote natin. At yung horizontal asymptote naman, titingnan natin, yung highest degree dito ay 3. And they have the same highest degree, which is 3. So our n and our m here are equal. So since equal man yung dalawa, yung n at saka yung m, sa highest degree ng numerator at highest degree ng denominator, so i-divide lang natin yung numerical coefficients. So you have 1 divided by 1, so you have y equals to 1. Since nakuha na natin yung asymptote, pwede na natin yan makuha din yung range. So kung ano yung ni-restrict dito sa horizontal asymptote, yun din yung ilalagay natin sa range. Hindi na natin kailangan pang isolve ang x in terms of y. Kundi, the range is just a set of real numbers except positive 1. Yung anong ni-restrict dito sa horizontal asymptote, yun din ang i-restrict natin sa range. Now, for step 4, we need to construct table of values and we need to plot the points. So, first, anuhin muna natin yung mga asymptotes. I-plot muna natin yung mga asymptotes. This is for the x equals to negative 3. This is for the x equals to positive 2. This is for the y equals to 1, which is our horizontal asymptote. And this is for the vertical asymptotes. And sa pagpili ng mga points, yung sa left side at saka right side ng mga asymptotes, yun ang mga pinili natin ng mga points. Pagkatapos niyan, i-substitute lang natin yan dito sa function natin, so you'll have these points or values ng mga y natin. So dahil nakuha na natin yung mga values ng y, we can now plot these points. I-plot na natin yung mga points natin. Yung ito naman yung intercepts. So after natin yan ma-plot, then i-connect na natin yung mga points. And ma-observe natin, isa lang man yung point dito, pero meron ka mang asymptote. So, nagagamit ka lang ng smooth curve. Yan, yung smooth curve na mag-a-approach sa asymptote, pero hindi siya mag-touch or magpa-pass through lang. Ito naman din, yung dalawang points natin i-connect, tapos yung ano lang natin, yung smooth curve lang natin, ay approaching, mag-a-approach lang talaga yan, dun papunta sa asymptotes. pero hindi yan mag-touch or even mag-pass through. So, pero dito sa gitna, pwede kang mag-pass through. Kasi, yung wala mang restrictions dito sa gitna. So, ang mangyari lang, i-connect mo lang yung points, i-observe mo lang kung ano yung flow or ano yung direction niya. So, you'll have to connect the 4 points, and you notice na pa-upward siya. So, i-follow mo lang na malapit siya sa asymptote, yan, or mag-a-approach talaga siya sa asymptote. At ito na yung graph natin. So, marami ba tayong natutunan for today? And I hope you learn a lot, especially on the definition about rational functions. At ngayon, marunong na din kayo magde-differentiate ng rational function, equation, as well as rational inequality. At marunong na din kayong mag-observe ng behavior ng graph ng rational functions. So, thank you and God bless.